Hey guys, here is lesson 7.2 and 7.3. We're going to combine both of these lessons today in order to consolidate some time. They're pretty much the same exact lesson. They just literally switched the wording around. But I think that the reason they did that is to give you extra practice with multiplying with whole numbers, but I feel like we'll get plenty of practice with that. So we're just going to combine the two lessons, but here we go. Our essential question for this first lesson is how can you use a model to show the product of a fraction and a whole number? So we are actually getting into multiplying fractions, but for today, we're just going to multiply fractions by a whole number. And if you've been paying attention during math moves, we've already started working on multiplying fractions by whole numbers. We haven't done a whole lot with models, but we're going to kind of see how that plays into this today. All right, so it says Martin is planting a vegetable garden. Each row is 2 meters long. He wants to plant carrots 3/4 of each row. How many meters of each row will he plant carrots? Okay, so each row is going to be 2 meters long. And then we know he wants to plant 3/4 of each row as carrots. So how many meters of each row will he plant as carrots? So what we're going to do is we're going to multiply our 3/4 of the row times 2. So they're wanting you with this first problem is to use fraction strips. And I know y'all don't have fraction strips available at home or even in the classroom. We don't have those things available to us. So we're going to have to kind of think a little bit outside the box for this. Okay. So it says find 4 fraction strips with all of the same denominator that fit exactly under the 2 holes. So we know that we need 4 of them because our denominator is 4. Now when I know that I can have, if I have one whole, I can split that whole into 2 parts. So that would be 1/2 and 1/2. And now if I have 2 wholes and I split both of the wholes into 2 parts, I'm going to have 4 parts all together. So I didn't even, for this one, need fraction strips because I could use my thoughts. And I know that I could divide up 1/2, or I can put 2 halves to equal 1 whole, and so then 4 halves would equal 2 wholes. So now what they're wanting us to do is circle 3/4 of 2. So this is 1/4, 2/4, 3/4 of 2, 3 sections of 2 wholes. So now we've circled that. It says complete the number sentence. 3/4 times 2. So that would be, if we added 1/2 plus 1/2 plus 1/2, we are going to get 3 halves. But we don't want to leave it as 3 halves. We want to reduce that fraction. So I know that 2 will go into 3 one time with 1 left over. So it would be 1 1/2. So Martin can plant carrots along 1.5 meters of each row. Okay, so you're probably thinking, OMG, Miss Austin, or if you're going way too fast, it's a lot to process. And it is, and I realize that. I think the next strategy that we use is going to be a little different. This one is really hard. I want to show you what it looks like, but it's really hard because you don't have the fraction strips. So it's going to be a little bit harder to kind of visualize it without having the fraction strips available. So let's look and see what could we do instead of that. This is the way I'm more than likely going to see you doing. I'm probably going to be doing this a lot more than the fraction strip way. It says, in this investigation, you multiplied a whole number by a fraction. You can also use a model to multiply a fraction by a whole number. We like models. Models are easier. We can draw models a lot easier than we can produce fraction strips. Margot is helping clean after a class party. Yay, Margot. There are 3 boxes remaining with pizza in them. Each box has 3/8 of a pizza left. How much pizza was left in all? So there were 3 boxes of pizza but they're not whole pieces or whole pizzas. There's only 3/8 of a pizza left in each box. So how much pizza was left in all? So again, we are going to multiply our 3 wholes times 3/8. But let's see it as a model. So we're going to place 1/8 fraction circle pieces on each circle to represent the amount of pizza that was left in each box. So the pizza left in each box we know is 3/8. So I'm going to shade 3/8. 1, 2, 3. There's 1. So here's one box. 1, 2, 3. There's 2 boxes. 1, 2, 3. There's 3 boxes. So now each circle shows 3/8 of a whole. And 3 circles show how many eighths of a whole. So how many, basically what they're saying is how many parts did we shade? We shaded 9 parts. So we have 3/8 plus 3/8 plus 3/8. So if I put a little plus sign right here, that's going to give me 9/8. So that's the same thing as saying 3 times 3/8, which is going to give me 9/8. Yay, you just multiplied, like I said, a little bit simpler than that first one. Or we would say 1 1/8. So we could say 9/8. Margot had 9/8 or 1 1/8 boxes of pizza left. Like I said, I feel like this way a whole lot simpler than that first way we just did. It just shows visually it's a little bit easier to comprehend. Okay, so now you're still probably going to see these with the fraction strips. So I don't want you to be like super surprised if you see them on a quiz or a test or whatever, which is why I went through it. But more than likely, you're just going to use the fraction model instead. So 5, 6 times 3. So what they did, they already modeled it out for you. 5, 6 times 3 is going to give you 1, 2, 3, 4, 5. And I know my bottom number is going to be 2, so it would be 5 halves, which is equal to 2 1/2. 2 wholes and 1/2. All right, this one, we have 2 times 5/6. So if I added these up, I have 1, 2, 3, 4, 5, 5/6 plus 5/6. Equals, remember you don't change your denominator, you just add your numerator. So that would give me 10/6. And I always want you to reduce it. Or you can write your 10/6, but make sure you reduce it. That would be 1 4/6. Still, I can't leave that as my answer. So that's going to be equal to 1 2/3. So this would be my final answer. Yay! A whole lot easier. All right, so we're going to do a couple of these together so that we can actually model it out. All right, so this one is 5/12. I'm going to try to draw this with 12 pieces. This is the best I could do. Actually, you know what? It's probably going to be easier is if I did rectangles and divided it up like this. It's probably going to be the easiest way. Like I said, it's not going to be completely even, but it's going to be a little bit easier to see. And they don't ask you to draw a model, so if you can do it without drawing a model, that's perfectly fine with me. All right, so now I have 5/12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I add up 5/12 plus 5/12 plus 5/12, that's going to give me 15/12. Remember, your denominator does not change. It stays the same. I can't leave 15/12 as my answer, so I need to reduce it. I know that 12 are going to 15 one time. There'll be 3 left over, so 3/12. still is not reduced, so that's going to be 1. I can divide both of those by 3, so that would be 1/4. So 1 1/4 would be my answer. Okay, so if you can add fractions, you can multiply fractions. All right, so I want you to do number 4 on your own. Try that one on your own. So pause the video and then check your answer. All right, so I've already drew all of this, so I'm going to add 1/3 9 times, so that would be 9/3, and that would be equal to 3 wholes. Okay. All right, so on your own, I want you, actually, let's go ahead and do number 5 on your own. Pause the video and then check your work. All right, hopefully when you did it, you got 28/8. So that would reduce to 3 4/8 or 3 1/2. All right, so on your own, I want you to do 6, 7, 8, 9, 10, 11. All right, so now we're going to look into, you're going to go back to that in just a few minutes. We are going to do the same thing with this one, except we're just going to do some of these practices. I take that back. I do want you to be able to multiply and to show it as multiplication. So we're just going to skip this front page and we're going to go to the example. This should be on page 300. So this one, it says Kristen brought in 4 loaves of bread to make sandwiches for a class picnic. Her classmates used 2/3 of the bread. How many loaves of bread were used? Okay, so we're going to shade 2/3 of 4. So we have our 4 loaves. We're going to shade 2/3 of each of those loaves. So I know I'm going to go ahead and divide each of the loaves into 3 pieces. And we're going to shade 2/3. So I'm going to shade 2/3 of each of those loaves. Just like that. All right, so now we're going to rearrange the shaded pieces to fill in as many holes as possible. So basically, we are going to, we knew I have 1, 2, 3. This is 1 hole. So I'm going to shade 1 hole right here. 1, 2, 3. Here's another hole. And then I have 2/3 left right here. So I'm going to divide this up into thirds and I'm going to shade 2/3 of that last one. And then this one, there's nothing there, so we can't shade anything. So what we would say for this one is we would have 1, 2, and 2/3 shaded. So 2 2/3 of the loaves of bread were used. How we would see that as an expression, we would write the expression to represent the problem. So we would have 2/3 times 4, which is what we did that in model form. And then we would multiply 4 by the number of third size pieces in each hole. So we know that there are 2 third size pieces in each hole, so we would have 2 times 4. And our denominator is your 3. So then we would have 2 times 4 is 8, so we would have 8. 3 stays the same because you're multiplying 3 times nothing. Or 3 times itself is 1, so it would be 3. Then write the answer as a mixed number, so you would have 8/3 or 2 2/3. Now, you're probably thinking, well, I don't really understand that much. All right, so let me show you as a different expression. I have 2/3 times 4 over 1. Now, 2 times 4 is 8. 3 times 1 is 3. That's where we would get that from. It's doing the same thing. You're multiplying. You're just, because remember, when you have a whole number, in order to multiply it and make it a fraction, you would just put it over 1. Okay, so it's essentially it's the same thing. They just wrote it a little bit differently. So you can actually write it. I would prefer y'all to write it this way so that I know that you know your denominator is being multiplied by 1 instead of just putting it as your denominator. Okay, so if we do it that way, let's look at letter A at the bottom. We have 4 over 1 times 7/8. I'm going to go ahead and put it over 1 because I know I'm making it a fraction. I know how to multiply fractions because we've done that in our math moves. You just multiply all the way across. You don't change anything. That's where it's a little bit different from adding and subtracting. When you multiply, you just multiply across. So I have 4 times 7, which is going to give me 28. 1 times 8 is 8. Now, am I going to leave it as 28/8? For sure not. So I know that this will go into, 8 will go into 28 3 times. How many is going to be left over? I'm going to have 4 8s left over. I'm still not going to leave it as 3 4/8. I need to reduce it. I know that 8 and 4 are divisible by 4, so that would be 3 1/2. So that would be my final answer for that one, which looks very similar to something we just did on a different page, but that's okay. All right, so this one, I want you to pause it real quick and go ahead and write how you would multiply this. Hopefully, this is how you have it. You would have 5/9 times 12 over 1. So then we would just multiply it like we would. We know that 5 times 12 is 60. 9 times 1 is 9. Now I can just reduce my fraction. With this way, you're always going to have to reduce. So sorry, tough apples for you. When you're multiplying by a whole number, it's always going to give you a number greater than 1, so you're going to have to reduce it. But this is going to be probably the easiest way for you to do this. All right, so I know that 9 will go into 60 4 times. Sorry, 6 times. All right, so I'm going to put 6. I know that 9 times 6 is going to give me 54, so that leaves 6 left, 6/9 left. Now, I know that I can't have 6/9 because both of those are divisible by 3, so if I divide both 6 by 3 and 9 by 3, that's going to give me 6 2/3. Now I know that that is the smallest possible fraction, so I am good to go. All right. Let's try a couple of these on our own. This one, multiply the numerator by the whole number, write the product over the denominator, write the answer as a mixed number in simplest form. All right, so we have, I'm just going to write it over 1. I know 3 times 2 is 6, 1 times 5 is 5, and I'm going to write it in simplest form as a mixed number because that's for sure what they wanted us to do, simplest form. So that would give me 5 will go into 6 one time with 1 left over, so that would be 1/5. Okay. Like I said, takes practice, especially when you're putting in the simplest form. That's probably going to be the hardest part of this. You should be able to do all of the other stuff that goes with it, but we're going to do a couple more together, just that way you feel comfortable and I feel comfortable letting you go on your own. All right, so let's do number 2. If you want to rewrite it, you can. I'm not saying you have to. Sometimes it's easier if you rewrite it, but you know, you do what works for you. 2 times 5 is 10. 3 times 1 is 3. I know that 3 will go into 10 3 times with 1 left over. Bring down my 3. So that one we should have gotten 3 1/3. All right, this next one I want you to do, and I'm going to rewrite it up here so that I remember that's my answer. I want you to do number 3 on your own, pause the video, and then come back and check. All right, hopefully you ended up with 4 as your answer. 6 times 2 was 12. 3 times 1 was 3. So then I know that 3 goes evenly into 12 4 times. All right, here's another one that I want you to do on your own. Pause the video and then check your work. All right, you should have gotten 2 6/7. If you did, kiss your brain. Nice job. All right, so now what I'm wanting you to do on your own, I want you to do 5, 6, 7, 8, 9, 10. Flip to the back, 17, 18, and 19. Okay, don't forget you have these over here on this other page, page 297, that you need to finish doing. There's like 6 problems on this one. You can do that. Show your models if you need to. Now that you know how to do it just multiplication wise, you can do that way as well. Just make sure you know how to use the models, and then do these few problems on this one. Not too hard, but I know you can do it. All right, have fun, guys. Bye.